The sieve of Erasthenes is an ancient, historical, and instructive process for finding prime numbers. Now, to find very, very large prime numbers, it's not real practical, but for most practical applications of prime numbers, it's all we need. Okay, so let's see, we start by crossing out, let's just start by obliterating 1, which was just kind of there to hold its place, because it's not under consideration, it's not a prime number, and we know that. Now, let's go through and just cross out all the multiples of 2. So we'll cross out 2 and 4 and 6 and 8 and 10 and 12 and 14, 18, 20. And actually it's clear that we're going to cross out each number in each of these columns, because those columns contain the even numbers. It wasn't really even necessary to write all those numbers down, but again, there's a pattern here that can be shown pretty well if we do that. Okay, now, next thing we do is we cross out all the multiples of 3. And I crossed out all the multiples of 2. I also crossed out 2, which I should not have done. Let me see if I can white out that cross out. There, 2's restored to its original purity. Now, 2's not crossed out, but maybe we put a little check mark next to 2 to indicate that we've crossed out all of its multiples. Now we're going to do the same for 3. The very next number we get to that hasn't been crossed out, we cross out all the multiples of 3. Now let's just note, what's the first multiple of 3 that we cross out? And what does that number have to do with 3? Well, the first multiple of 3 we get to cross out is 9. Of course, 6 is a multiple of 3, but it's already been crossed out. Let's see, I'm going to cross the 9 out in red with kind of a backward cross, and then I'm going to use blue to cross out the rest of the multiples of 3 that haven't already been crossed out. So we cross out the 15, and then we'll cross out the 21, and then we'll cross out the 27, and then let's see, 33 is next, and 39, and 45, and that's it for the multiples of 3. Now the multiples of 3 have been crossed out, and we note that 9 was the first one. We don't have to cross out the multiples of 4, do we? Because they've already been crossed out. Why have all the multiples of 4? 8, 12, 16, 20, 24, 28. They've all been crossed out. Now how did I know that before I looked? Well, a multiple of 4, since 4 is a multiple of 2, any multiple of 4 is going to be a multiple of 2 also, and they've all been crossed out because we've already crossed out the multiples of 2. Okay, so let's see, next number is 5. Now, without looking, what do you think the first number is going to be that we have to cross out? Well, we see that 10 and 15 and 20 have all been crossed out. The next one we have to cross out is 25. Let's see, I'm going to cross that out. I'm going to cross my multiples of 25 out with red lines going in this direction, just to distinguish from the multiples of 3. Okay, so let's see, if I use a big blue mark to cross out the remaining multiples of 5, well, I'm going to get 35, and it looks like that's it. Okay, so 35 is the only multiple of 5 that actually has to be crossed out on this list. Of course, there'll be others if the list continues. Okay, so let's put a little check mark next to 5. We've crossed out its multiples, and let's move on to 7. Okay, let's put a check mark here so we don't forget. And let's see what we do now. We have to cross out the first multiple of 7. What do you think the first multiple of 7 is going to be that hasn't already been crossed out? Well, that's going to be 49. You can check that out for yourself. I'll use a horizontal red cross to cross out 49. And then I'll take the blue pen, or the blue marker, and cross out any other multiples of 7 that might still be here. Of course, 14 and 21 and 28 and 35 and 42 have already been crossed out. So that shows us that, again, 49 is the first one, has to be crossed out, and 50 is the only number left. Now let's say that we had a much longer list. Okay, let's say the list went down to 200 or 1,000 or 1,000,000, and we'd crossed out all the multiples of 2, 3, 5, and 7. The next number we'd have to check would be 11. Now what's the smallest number that you think we would cross out from 11? Well, you see that the first multiple of 2 that got crossed out was 4. And then the first multiple of 3 that got crossed out was 9. First multiple of 5 was 27. The first multiple of 7 was 49. And we also note that after 2 and 3 are crossed out, then everything left up to 25 is prime. After 5 is crossed out, everything left up to 49 is prime. If we then cross out 11, well, 11 is each of these numbers is the square of the prime that we started with. Okay, 11 squared is 121. That means that the first number we'd have to cross out would be 121, and that means that every number up to 121 on this list would already be prime after we've just crossed out the multiples of 2, 3, 5, and 7. Then after crossing out the multiples of 11, the next thing would be 13, which has a square of 169, and the very first number we'd have to cross out would then be 169. And after having crossed out all the multiples of 11, it follows that we have all the primes up to 169. So this sieve method both gives us the primes and shows us an important property of primes, or of the process. Okay, after the 5s are crossed out, everything is prime up to 7 squared equals 49. And after the 7s are crossed out, everything's prime up to 11 squared, which is 121.